example, let's look at disease detection. Look at this tomato leaf. Do you see the spots? I see them too, but what exactly is the disease? That's where AI can help. Instead of guessing, a farmer can take a photo of the leaf using a mobile application. I am not prompting any specific application here. There are many available on the Google Play Store or Apple App Store. Typically, these apps use computer vision to analyze the image and compare it to thousands of known examples. And in just a few seconds, you can get a clear answer. Now the farmer has a clear diagnosis and can act quickly to protect the crop. This process is faster, more accurate, and helps prevent the disease from spreading to healthy plants. And that's the power of AI in action. It helps farmers make smart decisions without delay. Another great example is optimizing irrigation, deciding exactly when and where to water based on weather predictions as well as soil data. Yes, this is a more advanced solution and it's often found on larger farming operations. To make it work, you need to have soil moisture sensors installed across different zones on the field. These sensors send real-time data about how wet or dry the soil is. At the same time, an AI system checks the local weather forecast. Now, instead of watering the entire field, the AI might say, rain is expected within 24 hours, skip irrigation for the next 12 hours. Then, recheck the forecast. Or it might flag a problem like Zone 2 is dry in comparison with other zones. Activate irrigation, 5 minutes only in that area. This approach helps farmers save water, reduce energy use, avoid overwatering or underwatering, and keep crops healthier and more resilient. AI makes irrigation smarter, and that means better harvests and fewer resources. Now let's look at even more complex application of AI called yield prediction. It's predicting crop yields before harvest. Let's look at specific example. A corn farmer has been collecting data for the past 3 years. Things like rainfall during the growing season, soil quality and moisture, planting and fertilizing dates, satellite images of crop health, actual harvest weights from each field. And with this data, the farmer can use an AI platform during the current season to combine past records with current field conditions, including weather, real-time sensor data, and drone imagery. The AI analyzes it all and says, based on the current growth and historical trends, Field A is expected to yield 6.8 tons per hectare. That prediction helps the farmer plan storage space in advance, negotiate better prices with buyers, adjust fertilizer or water use in time to improve results, and avoid surprises at harvest. Yield prediction turns raw data into a clear forecast, giving farmers more confidence, control, and planning power. So let's wrap up. How does AI work? It learns from examples like photos, spots patterns in data like weather plus yields, and makes decisions like when to water crops or when to harvest yield. So as you can see, AI is just smart use of data to save time, reduce waste, and improve results. In the next lesson, we'll look at the main differences between traditional farming and smart farming, as well as clarify why smart farming is different from conventional farming.